Good morning, good afternoon. My name is Robert Schmid, also known as Mr.IoT. I'm the Chief IoT Technologist for Deloitte with a deep passion for all things digital. This week on Coffee with Misconnected and Mr.IoT, Kelsey and I talking with Maria Gorlatova and Robert MacInnis. Maria, you are a professor at Duke.
That's right. I just joined a month ago. I was a research scholar at Princeton just before that.
Well, welcome to the show. Thank you so much for joining us. I titled the show From the Cloud into the Fog, and you know what that means for IoT. I spent a lot of time talking about edge. And so what is fog? What is fog computing? And how is this different from cloud? Just give us, what do you tell your students?
So basically, the idea of fog is to extend the cloud-like functionality closer to the users. So this is the idea of taking computing from data centers much closer to your endpoint devices. It generates all sorts of opportunities. You can offload processing from your IoT devices to make them last longer. You can create lower latencies that are possible with the cloud. You can bring what I'm particularly excited about is bringing advanced intelligence closer to the users. The kind of things that currently are done in data centers, that you need to translate all of your information to the centralized authority. This can all be done locally, faster, and for more devices. So it enables a completely different IoT experience, completely different scale. I sincerely, firmly believe that fog is what we need to take IoT to its fullest potential.
It's really interesting. I was going to ask, before you explained it, what connection it actually had with IoT, but you really answered that in your question, and how it's really progressing some of the applications. Are there kind of specific applications you think will really be enabled or have already been enabled by some of the fog computing power that's out there?
Some of the ones that are oftentimes discussed are video analytics. That's one of them, as it requires quite a bit of processing capabilities, and doing it faster on the edge reduces some of the privacy concerns that you would have with sending it to the cloud. The one that I'm particularly excited about is augmented and virtual reality. I think it's absolutely you need something like fog to actually make it realistic. So you need the local computing, you need the power of the cloud brought closer to you. Drones as well, that's also a big one, that to make actual networking of drones practical, you really need fog. I don't know if Robert has other applications in mind.
Well, Robert, I want to go and introduce you. You're the CEO and founder of AetherWorks. I almost want to wonder if you didn't like the term fog, so you called it ether. But welcome to the show. Thank you for being here. You're another big contributor to OpenFog, beside, your day job, obviously. Tell us a little bit about yourself. Tell us about AetherWorks. And, I'd love to hear some of your examples. I know we started talking about drones. I have a personal affinity to drones, so I'd love to hear your thoughts. But maybe you have other use cases you want to talk about.
Drones are great. Great. Robert MacInnis. We run Active Ether here at AetherWorks. We're a software research and venture development firm focusing primarily on fault-tolerant distributed systems. If you look at what fog computing really is, it's sort of a global fault-tolerant distributed system that it enables the most consumption of the most geographically appropriate computing power, as Maria has mentioned. So why would you choose to do that? Well, again, you've got low latency requirements. You also have the torrent of the tsunami of data that is coming from these 20 billion new IoT devices that are going to be connected to the internet by 2020. And that used to seem like a really long way away, but it's less than a year and a half away now. It's not the future anymore. So being able to utilize any of the spare computing power that lies between you and a cloud data center, which in New York City is 350 miles away to the nearest Amazon data center. There are literally millions of opportunities along the way to get that processing done. An additional use case to the one that Maria mentioned that we find very important is the orchestration of the deployment of pre-trained neural networks closer to the data sources. You've got high fidelity data coming off of high resolution cameras, et cetera, and sending that halfway across the country just to be dropped because there's the cat in the picture is silly. Being able to place those neural networks closer to those actual data sources is an important use case and one that we're exploring.
So just a question for you as people think about this and get their minds around how it either works with cloud or maybe is used instead of cloud. How do you have that conversation, and are there really different ways for the fog and cloud to work together, or can they work independently?
So fog encompasses everything from the edge to the cloud. We've kind of inadvertently over the last few years introduced the concept of geography into our computing environments. Cloud basically just means really far away. And edge is obviously right where you are. Fog is edge, cloud, and everything in between. Edge computing obviously is useful for some circumstances. Again, nearline computing, pre-processing of IoT sensor data, et cetera, et cetera. But you also there are serious benefits to cloud computing, right? You've got the ability to collect data from all over the place and do sort of non-time restricted data processing. So you can post-process this data to look for long-term trends or trends that are coming up from your entire global fleet of little IoT sensors. It's a great place to perform broad historical analytics and also to send down then guidance based upon those kinds of learnings. Executive dashboards are also a prime place for cloud stuff. So execs like that.
Maria, I'm curious. So fog, it sort of reminds me of the term cloud maybe 10 years ago, right? Nobody quite knew what cloud was. It was sort of like this, a little scary piece out there. You know, hey, I'm going to put my service now to someone else and they're going to run it for me. How's that going to work? And so now we have fog, which means I'm even going to put my compute power closer to end users. What do you find you really research on this right now? Where do you as a university go and put your effort in terms of research around this? And how do you see people respond to the idea of putting compute power that close to the user? I mean, come on, in the old days, we put a firewall there. We kind of like blocked the compute power as far behind the highest wall we could. And now we're going to have it sitting right next to you and I. So what's the research you're doing and how do people feel about it?
Yeah, so that's a great question. So research-wise, what's very interesting for myself and for the other research groups out there, and there are many all over the world, are all the different, first of all the different opportunities that fog enables. So, for example, that we can enable the next generation of augmented reality. So if we change our processing just right, we really can take applications to a completely different level. And that's one very interesting area of research. Another one is how to restructure your applications and your workloads and your processing to best take advantage of the properties of the different parts of fog. So we instead of let's say that we have a machine learning operation. It's not that we do it all locally on the local devices, and it's not that we do it all on the cloud. It's that we have to change how the underlying algorithms run to best take advantage of cloud's capabilities and best take advantage of the local capabilities. And that's the geographic distribution, like Rob mentioned, and the heterogeneity of the underlying platforms makes for completely different research questions. So your mobile device, for example, really wants to save energy, and your local node has this advantage of returning your results in the loop very, very quickly. But cloud has advantage of massive scaling, for example, of this massive parallelism. So we are, as researchers, we are not used to these types of paradigms working together. We are used to studying them in isolation. It's very exciting. You actually have to go and look at the underlying assumptions of just about every algorithm that is currently deployed to make sure that it works. It's possible best in those types of conditions. So those are the two key research directions that I see. There is also resource allocation. Questions like what you place where, those are how you actually take care of some of the things that Rob mentioned, such as For example, in a distributed system, in cloud settings, it is easier to prevent a node failure, for example. So how you work with that in fog conditions, that's another research direction. How people respond to it, that's actually, it's generating a lot of excitement right now. So I just went to one of the Microsoft research events last week, for example, where edge computing was one of the themes that had a panel of academics, and it was one of the themes of the event, major directions there. What excites different things excite different people. So for some cases, it's very exciting that you no longer have to send all of your data to the cloud. This is a big bottleneck for many applications. This is actually a big issue, that you have to over provision your network, that you have to pay for all of those resources that they're just not used in a good way. So some people in the industry really get excited about that. That's a big one. Privacy is a very interesting potential benefit of fog. For example, if you restructure neural networks just right, we no longer have to send raw data to the cloud. We send some kind of an obscured variant of it, or we do all the processing locally. We don't have to sometimes even send raw data for training advanced models. So that also speaks to many applications, and that has the potential of enabling applications where they're not possible right now. So in hospitals, for example, or in other private conditions. So there are folks out there who see it as a negative, but I think overall the community, from all I see, everybody's really excited about this.
It's really interesting. Yeah, I was going to ask about the security, and you're good at reading my questions because you answered that one as well. So Robert, maybe to you, thinking about business participation in some of this. I mean, Maria, you mentioned having to look at reconfiguring or thinking about how products are now needing to consider some of the fog computing in their design. How are businesses and marketplaces really getting involved in fog, and is the traction from conceptual to action, really strong, or how are you seeing that in the marketplace?
Robert, you're on mute by accident.
There we go.
Thanks for being back.
We're taking a very broad approach that enables a lot of the conceptual to actually become a part of fog. What I mean by that is we're creating a global network for compute. A global network for compute where you can have arbitrary individuals running arbitrary or precise software from arbitrary software publishers in order to provide a pervasive computational environment that essentially spans the continuum from the phone in your pocket to the laptop on your desk, through workstations in your office, some servers sitting around in a back room somewhere, nearline data centers, and literally I look out this window in Manhattan, all of the millions of opportunities you can see in the windows, buildings that again lies somewhere between here and Northern Virginia. The most exciting aspect of all of this, or most challenging actually, and exciting to have solved, was why would people engage? Why would you let the spare processing power on your phone be utilized for absolute matter? Systems have networks like this have come up in the past for decades, really. SETI at home is one of the best known ones. They search for extraterrestrial intelligence. It's a great computing system, so don't confuse the technologies. But it is similarly an open network where people allowed some computation to be run on their systems because the systems weren't doing anything, and most of the systems around us do very, very little most of the time, and are very capable as well. And that was people joined because it was interesting. right? It was exciting. It was neat technology. There are a couple of other systems, other networks like that are enabling, additional searches for cures for cancer and things like that. And those, the incentive there for people is that they feel like they're contributing to a big cause. So how do you keep a network like this stable? How do you put it together, and how do you properly incentivize people to participate in this global network? And we are enabling people to get paid for their spare. Pretty exciting.
If you're just joining this conversation now, you're watching Coffee with Misconnected and Mr.IoT. Today, our guests are Maria Gorlatova and Robert MacInnis, and we're talking about fog computing. So, Robert, I gotta ask you about this. So, let's just assume it happens, okay? I'm not really questioning that there will be fog or whatever it's called, right? There will be computing happening on the edge, and there will be networks. I'm wondering who's gonna own those? And when I say this, what I mean by that is this gonna be a business-driven effort? Is this gonna be a consumer-driven effort? And I ask this because at the end of the day, there are all these consumer devices out there that are all gonna have compute power in themselves, right? And so in a way, am I gonna become my own data center? Am I gonna be competing with Amazon and gonna be the fog computing guy, and I'm gonna run my Airbnb at home, renting out compute power? Or am I going off into sort of like La La Land here? I'm curious.
No, that's not La La Land at all. It won't be just you, though. It'll be the other 5 billion endpoint computing devices.
Yeah, but mine is going to be so much better than yours, Robert, because I'm in Maui and you are in New York, and there's going to be 5,000 of yours, and I'm going to be the only one in mine. I'm just kidding, obviously.
And to be fair, island nations are got a ton of interest from folks in Southeast Asia, and all across India, which I know is not an island nation, but the telecommunications infrastructure is leaves something to be desired. Intermittently available, apparently a lot of cases, and being able to provide the semantics of cloud computing in a more dynamic, fault-tolerant, resilient way is pretty incredible. So, will you be getting paid for your spare time? Yes, I believe so. We're actually doing some of this again in India, and hopefully this goes through next week in South Africa, enabling folks to get paid for their spare computing time, and then utilizing what we're paying them in to pay for their power bills, for example. Right? Pretty neat. There are all sorts of other kinds of relationships that can change based upon this dynamic, where you're, for example, paid to participate in a telecommunications network as opposed to paying to participate in it now. So we've been in talks with major telcos around the US that are actively interested in discussing how they can reduce their customers' bills by enabling their customers to keep their phone plugged in just a couple hours a night and utilize the spare computing power on their phone. And by the way, that is not kind of dinky computing power. My phone is more power than any computer that I used during college. And it's just in my pocket doing it. It's over there, but it's doing nothing right now. It could be making money. It's pretty cool.
That is really interesting. I mean, how from like a government regulations or, how is that going to be handled or monitored, or are the business models and the regulations pretty flexible right now, where there's a lot of green space to be really creative? Because a lot of the things you mentioned just now are so exciting on so many levels, and really enable creative problem solving for a lot of our global needs. Do you think that regulations will keep up with some of that innovation?
We haven't run into anything that is prohibitive. I'm certain that the second anything gets popular, regulatory groups will work out whether or not they have a realistic or even unrealistic right or need to engage. But no, I don't foresee any problems. We do periodic reviews of all this kind of stuff, but it's new tech. It's evolving. It's an exciting new landscape, and it's pretty clean sailing ahead as far as we see it. Great.
Maria, you can have the World Fog Congress come up in San Francisco, October 1 to 3rd. Actually, you guys were totally awesome and opened up the website fogcongress.com/coffee, and there's even a coupon code coffee, capital COFFEE, that gives you 25% discount for people who want to join. So thank you for that. What is Fog Congress? What's the World Fog Congress? By the way, thank you for not having it in Barcelona because it's this time much closer to me. But what is it? What do you guys do there? Just for anybody that's interested in this, talk a little bit about it, and maybe also talk about Open Fog while you do that.
Definitely. So Fog World Congress is in its second year of installment. It was so I went last year. It's an exciting event. It gathers people from all over industry, academia, as well as government. It showcases it introduces the world of fog to you in the complexities and the advantages and the opportunities. So exciting keynote speakers, very good, very positive atmosphere, and a good mix of academics and industry people I found last year. So I don't know if Rob is a speaker. I'm one of the speakers. I'm very happy to be presenting my research. I know that some of our colleagues who work on DARPA programs that work in related areas will be there. So that's going to be very exciting. So
You mean every DARPA will be a part of the Fog?
Not so much a part of the Fog, but DARPA has programs that are working on related challenges. So there will be people who are doing that. So
you said DARPA. I'm sorry, I misunderstood. My bad.
Yeah, so it's an exciting event. I really enjoyed it last year, and I'm looking forward to going this year as well.
Likewise.
It's exciting. So maybe one last question, Robert, for you. How did you really get into this, and what keeps you really passionate about it?
I was about 9 or so, and I was had my first computer, and had it downstairs. I had a lot of computers in the bedroom, and I was trying to get some 3D graphics thing to work, and it had this really long progress bar going along. Come on, move along here, and looked over, and there's another computer nearby. Can't we just tie these two things? That's got power. It's doing nothing. Why can't we just kind of jam these two things together? So I think that literally that one experience has driven my entire research career. Did undergrad and doctorate out in St. Andrews in fault-tolerant distributed systems for deployment architectures, and started up AetherWorks here in New York City, focusing again on fault-tolerant distributed systems. So fog computing is essentially the manifestation of the four important concepts of being able to provide a pervasive service-oriented computing environment that just takes care of itself. And you're able to utilize the most geographically appropriate computing power to be efficient about bandwidth, to have the fastest processing power and most processing power as close to you as possible, without really having to worry about how it all goes on. Fog taking care of all of that deployment and endpoint composition for you. So it's just been kind of a long continuum. There was no sort of aha moment, and I guess I don't guess, I'm certain that I'm lucky to have the opportunity to bring this technology to market. So it's great.
So this is going to be about at the end, and I have to tell you, Robert, the thing that occurs to me is when you talk about this, and I know you have some experience in this. I was in a gaming company for a long time, and in a way, we had fog computing for a long time in these gaming consoles, right? But I think the thing that it was missing is this fault tolerance, how there's multiple ones, like lots and lots of small ones that all talk to each other. And when 2 fall out, it doesn't matter because there's another 8 right there. So that idea that they all talk to each other now, and that in a way, I don't really need a computer anymore. All I need is a display device, which might not even be a display anymore, fascinates me. But I have a closing question for you, and maybe we'll start with Robert and we'll end with Maria. By the way, someone was asking me, what are you pointing at? And I was pointing at this Robert because he on my screen is on this side. So I want to make sure it wasn't about me. So Robert, Maria, fog. What do you have at home that's a fog device or a fog network? What do you run at home? I'm kind of curious. You guys are at the leading edge of this. What is fog for you at home, and how does it impact you?
We run Active Ether here in the office. We've got laptops on it. We've got actually a whole rig of Raspberry Pis if we wanted some kind of crappy stuff around. You know, we build test rigs. We want the full gamut of things. I should send some photographs around here. We're posting. Check out our Twitter. I'll post them later on. We have boards intentionally, so we just rip stuff out and make sure everything still works, even when we rip cables out. So yeah, for us, that's what we're doing with fog right here every day.
Maria?
For us, we also have Raspberry Pis. We have sets that play with how you would place machine learning type of intelligence differently between the Raspberry Pis and the cloud and the smaller nodes. We have GPU accelerators that work with Raspberry Pis that allows us to explore more advanced computational intelligence. And we have augmented reality sets. So I'm very excited about Microsoft HoloLens as helped by Fog. So we have that. And we're really having fun with exploring all the opportunities associated with that.
Well, we've come to the end of our coffee chat. And as always, by the time the last 5 minutes come around, I have 15 more questions. So thank you so much for being on the show. I really appreciate it. Please check out fogcongress.com/coffee and use the code coffee to get a 25% discount for the Fog World Congress, October 1 through 3rd in San Francisco. I will be there, and I will definitely see if I can get Kelsey there with me. And with that, please join us again next Friday, 9 a.m. Pacific, noon Eastern, for another Coffee with Ms. Connected and Mr. IoT. And if you missed any part of today's show or our last episodes, check out our YouTube channel. With that, thank you so much, everyone. Have a good one. Happy Friday.
Thank you. Happy Friday.
Yes.
Bye.